Hello my dear students, we are back with the one more session of periodic classification of elements. In the last session we studied about Dobriner's triads. So he arranged the elements in the increasing atomic mass. He arranged the elements with the similar properties into groups having 3 elements. He called it as the triads. So in the triad, the atomic mass of the middle element is the average of the first and the third element. But he could not classify all the known elements into triads. So his proposal was rejected. Next, Newlands proposed a law. He arranged the elements in the order of the increasing atomic mass, and he proposed a law called as Newlands law of octaves. So which states that every 8th element had properties similar to that of the first, but it was applicable only up to calcium. Hence Newland's law was also rejected. After Newland, many scientists continued to search for a pattern. So then came Dmitry Ivanov Mendeleev. He was a Russian scientist. He was the most important contributor for the early development of the periodic table. Okay. So the arrangement of the elements he proposed is called as the Mendeleev's periodic table. Okay. So this periodic table means it is the chart of the elements prepared in such a way that elements having the similar properties occur in the same groups. We can see a periodicity in the arrangement. So during Mendeleev, there were 63 known elements. Okay, so he arranged the elements in the increasing atomic masses, and he also considered the physical and chemical properties. So among the chemical properties, he concentrated mainly on the compounds formed by the elements which were reactive with the oxygen and the hydrogen. So why he selected oxygen and hydrogen? Because these two are very reactive and they react with almost all the elements. Okay, so he took the formula of the hydrides and oxides formed by the element. What he did was, he took 63 cards. Okay, he took 63 cards and he wrote the atomic mass, some of the physical properties, and chemical properties of the elements on each card. Okay, suppose if A is one element, he wrote the name of that element and the physical and chemical properties of that particular element. Likewise, he took one more card and wrote name of the element, physical properties, chemical properties. So likewise he did for all the 63 elements and he arranged that on the wall. Okay, and he observed that most of the elements got a place in the periodic table, and all the elements, they were arranged in the order of their increasing atomic masses. And also he observed that there was a periodicity, that is the periodic recurrence of the elements with similar chemical and physical properties. Okay, periodicity means the same properties of elements are repeated at regular intervals of time. I repeat, so if the elements are arranged in the increasing atomic masses, the properties repeats at the regular intervals of time. So on the basis of this, he formulated the law called as Mendeleev periodic law. Okay, it states that the properties of the elements are the periodic function of their atomic masses. Okay, so when the elements are arranged in the increasing atomic masses, the properties repeats at the regular intervals of time. This is known as Mendeleev's periodic law. Okay, so in this periodic table, you have groups and periods. So groups means the vertical columns. Here you can see the vertical columns. These vertical columns are called as groups. And you can see the horizontal rows. Okay, so these horizontal rows are called as periods. Okay, so the vertical columns are called as groups and the horizontal rows are called as periods. So this is the Mendeleev's periodic table. So in this table, totally there are 8 vertical columns. That is, totally 8 vertical groups are present. And totally 7 horizontal rows are there. These horizontal rows are called as periods. Totally 7 periods are present. So in the group, you have subgroups. So in each group, you have subgroups. That is, A and B are the subgroups. From group 1 to 7, there are subgroups. In the 8th group, there are no subgroups. Okay, and the elements in the same subgroup have the properties similar to the group. Say for example, the valency. The valency is similar. So the group 1 valency is 1 and the group 2 valency is 2. Group 3 valency is 3. Group 4 valency is 4. But group 5 valency is 3. Why? Because it should be 8 minus 5. Okay, hence group 5 valency is 3. And group 6 valency is 8 minus 6 is 2. And group 7th is 8 minus 7 is 1. The valency is 1. That means in the group 1, all the elements will have the valency 1. And in the group 2, all the elements will have valency 2. And in the last group, that is the 8th group, there was no information about the valency. Okay. And in the periods, when you move from left to right, okay, in the left side, the metals are arranged. So when you move from left to right, the metal characteristics will decrease and the non-metals will start. Okay, so these are the features of the Mendeleev's periodic table. Okay, so here you can see the periodicity of the arrangement. As I told, periodicity means at the fixed intervals of time, the properties will repeat. Take for example, lithium is there. Okay, so when you move a fixed interval of time, the property will repeat. That is, the lithium and sodium properties are similar to each other. Okay, so after sodium, when you move a certain time, the potassium will have the properties similar to the sodium. So at a fixed intervals of time, the properties may repeat. This is called as periodicity. Why it is called as table? Because it in the it is in the tabular form. Hence it is called as periodic table.